Hello, and welcome to Introduction to Python. Now we're going to learn about arrays, lists, and tuples. Go ahead and open PyCharm. Type PyCharm from your command window or go to your Windows apps and find a PyCharm, the one that we have installed recently. I opened it and I am not going to update my PyCharm IDE. You can go ahead and cancel your updates so that we can start right now. If you go ahead and click on terminal, you should be seeing the environment that we created last time. Okay, if you run this code, you can go to run and run, intro code, run. Finish with exit code 0. That means that there were not errors and it was successfully interpreted and run. Okay, now we're going to create a new file, and for that we're going to click on the top folder and click on right click, say new, and Python file. Go ahead and create a file named my lists or my arrays. This is just the name of the file so that we remember that this is where we're going to start learning the first basic things about Python. So do not add the Python extension because PyCharm is going to add it for you. The Python extension is py. You only need to click on the new file name and Python file, write the name and enter. Okay, from last time we imported NumPy and SciPy and pandas. So we're going to go ahead and do the same thing right now. We're going to say import. Look, the NumPy is going to help you find what you need. NumPy, enter as np. So this is just a shortcut so that whenever I call my NumPy functions, I only have to say np instead of NumPy function x, function y, just np for shortcut. So with NumPy, you can check the version that you have by saying print. This is a function in Python 3.8, and you're going to say np dot version, and NumPy knows what you want. If you run this, remember you go to run and then run, but also you can do Alt plus Shift plus F10. So Alt Shift F10, and then we're going to create run my lists, and the version that I have for NumPy is 1.19.2. It doesn't matter if it's 0.18 or if it's 0.17. It's just that some functions are going to have a little bit of more development for the newer versions. So that's my version right there. You should have something similar by the time you install NumPy. Okay, so remember that a computer is very simplistic. It doesn't know more or less. It doesn't know in terms of if you ask the computer, how are you? The computer only knows how to say yes or no. So you have to ask, are you good? The computer says yes. If you say, how are you feeling today? Then the computer gets confused. That meaning that you have to be very exact when you assign your values and when you do your operations. So let's go ahead and create a list, and let's name it my list 1 or list 1, wherever you want. This is just a name. It could be list A, list B, list X, whatever you want. It's just a name. make sure that you have no space in between your words. This is not good. When you have space, this is not going to work. You have to say a single string for your name. So my list, and a rule of thumb, you can combine capitals and lowercase letters for your variables. So you can say my list with capital, and could be list with capital L1. That's fine. But in that case, I don't need this underscore. So my list one, and then I'm going to say that it's equal to anything. This is some sensor values that you're reading from your experiments, or this is the grades from the class that you're teaching, or this could be anything. So it's 2, 5, 7, 11, 12, 23. 12, 23. So first thing, notice that these numbers are integers, and you can also add double numbers, or you can add fractions, such as 0.3. So this here, this is called an integer. Let's create a comment. Int type is 1, 2, 3, and then you have float 0.2, 0.567, and double. The difference between float, double, and int is that int is not, doesn't have a dot anything. It's just a real number, natural integer, or a natural 3, 2, 1. It's just a 1, 2, 3, 4 is a real value, and it could be a complex value too. But the point I'm trying to make is that it's not an integer. It is that it's an integer. Versus float, you can have 0.5, 8.5, what, it's anything. It's just a fraction. But the difference between double and float is that the precision of the numbers that you can have after the dot. Okay, for now we're only gonna care about how to deal with numbers in a list. So you can mix the type of variables that you have, but start by the very simple one, which is the integer. So my list one, and then you want to print that list. So you say print my list one, Alt Shift F10, and then you're printing my list here. Also, I want to know what that is, so I'm going to give it my list one equals comma my list one. Run. Now it says my list one equals to that very same thing. Very good. Now, if you were to print and adding \n, this will be jump line. So that's very useful in many cases when we're playing. So when we play with arrays and we're working with matrices. So this will be jump line. If you want to be just the same line, this will be like that. Run. Okay. Now next, if you want to access the numbers in your list, then Python starts indexing by 0. So regularly, you probably are used to saying 1. This is my position 1. Sorry. This is my position 1. This is 2. This is 3, 4, 5, etc. Okay, with Python, it's like C++ or C. You start from 0. So if you want to ask what is my first position, then you're going to say my first position is print no capital This is a function print. Then it's going to be a string that I'm going to say my first position in my list is. Then how you say that? You're going to say my list in position 0. So this is going to show you a number 2. So the first position in my list, which is indexed by a 0, is number 2. Run it. Yeah, so there you have it. My first position in my list is 2. Similarly, this is 0, 1, 2, 3, 4, 5. So let's see what is position number 5. We'll say number 23. So my fifth position in my list is 23. So that's how you access the positions in a list. Now, if you were to scale that list, you can say when your code comes to the next line, he knows that my list is already that bunch of numbers. So you can say my list is equal to the previous number that I had, the previous values that I had assigned to my list times 6. Okay. So if I were to print the same thing, my list now will be those numbers times 6. So 12, 30, and so on. My list. But what happened here? So when you multiply, when you are operating with the multiplication in a list, it does not scale in value. It scales in quantity. So previously we had only one set of numbers. Now we had 6. So if you want to scale the value, so go to, instead of 2, we're going to have 12, and instead of 5, you want to have 30, 6 times 5, and so on and so forth, then you have to turn this into an array. And that's why we wanted to bring NumPy into the picture. If you want to know the length of your list, right here is evident how many items or objects you have, because you can count them. 1, 2, 3, 4, 5, 6. But sometimes you import databases where you don't know how long the lists get to be. So if you want to know the length of your list, you type len, which is a function in Python. So len my list, and you are going to print the length here. So as I have it in this line, I'm going to say print the length of my list is, comma, len. So if you run this, it will tell you that the length is 36. Notice that 36 is 6 times 6. So if I am organized, I'm going to say this is my list 2, and my list 2 is my list 1 times 6. So I'm going to say this is the length of my this is the length of my list 1, and a new column, a new print that says the length of my list 2 is my list 2. So if you run this code, you'll get 6 and 36. So let's go ahead and comment these lines here. And now we're going to use NumPy to create an array instead of a list. So let's call my array capital M, Y, capital A, remember no space, 1 equals NP, because I'm calling numpy np dot arrange 5. And I'm going to say print quotation marks my list 2 equals comma my array 1. Or it's be easier if I say my array 1 equals my array 1. If I run this, I am going to get my array 1 equals 0, 1, 2, 3, 4. And it's because I asked for 5 elements. So Python starts from 0. Therefore, my first element is a 0. If I want to access those objects, so I would say print something to break these 2 comments in half, and then we can say print quotation mark the first object of my array is column comma my array at position 0. So if I run this, I get my array 1 as before, and then the first object of my array is a 0. Very well. And this process finished with code 0, meaning that there are no errors. And the same way, if I want to access the 5th position, I'm going to say the 5th object of my array is, let's run this. So there's an error because I have 5 objects, but I'm asking to access the 6th. Why? Because I start from 0. So 0 is 1, 1 is 2, 2 is 3, 4 is 5, 4 is 5. So that's where I stop. Therefore, I need to access position 4, not position 5. There you go. The last object is my array in position 4, which is my 5th element. So again, this is the first element, a 0. 1 is my second element, 2 is my third element, 4th element is a 3, and the 5th element is a 5. How can I verify this? If I ask for the length of this list, it will give me back a 5. So let's do the same thing. Print the length of my array is, and then comma, len, which is the function, my array 1. If I run this, I'm gonna get that the length is 5, even though my last object is a 4. And this happened because I asked for 5 elements, but when you import your database, when you read a file, you don't need to initialize the array like this. Your array will be whatever you're reading or whatever you're importing. Okay. So our first list was previously determined. Now, let's say that this even though this is an array, let's say my second list or my list 2 was my array 1, and that is a little bit confusing. So let's say my new list is okay. Then let's call my list 2 equals 6, 7, let's say a float 8.3, 3.35. NP pi, you can put that there if you want, 3.14, or you can keep using a string of only one character. So we have 678.35. We can put 674.835. Okay, I made this up. And if I print my second list, so let's say print, and then separate this by a comment like this. And I'm going to say my list 2 in the fourth position. So actually this is going to be in position 4, meaning my fifth element, because it's 0, 1, 2, 3, 4 for my array 2, or I'm sorry, my list 2 is, but I need to ask for my fourth position. There you go, it's A. I can also sum elements in my list if I say the sum equals my list 2, say position 2, plus my list 2 in position 3, run, and then I print my sum. So I didn't get any errors, and I can say then I can print the sum saying the sum is, the sum of position 2 and position 3 is comma the sum, and if you print this you'll get 12.35. But also another way to do this, if you don't want to create a new variable for that and you just want to check or debug your code, you can actually perform the operation inside the function. So print is a very versatile function, and this will give you 12.35 as well. Furthermore, if you were to change this value to a 0, then you can say, let's go ahead and say this for completeness. My sum of position 2 and my sum of position 3 is 4.35. So for those of you who are familiar with C and C++, you know that this will give you an error. But for Python, it's very evolved, much more, it's easier. So it does not, Python is fine with dealing with 4 as an integer and then 0.35 as a floating point. In C, you would have to turn this into a floating point by saying turn that into a 4.0, for instance. I mean, it's something so evident that will give you an error that they decided to fix it, and the programmer doesn't have to care about those things. So in your case, this seems very natural, but the computer or the compiler for C doesn't understand that. Versus in Python, the Python knows that this is an operation that is should be done. So internally, he turns the 4 into a floating point and turn it into a 4.0 so that you can do this operation with no problem. So now you can operate with your list and your values. Now let's look into tuples. Okay. So tuples are also sets of numbers or objects that the difference is that you create a tuple by saying tuple 1 equals, this is just the name. The way you create the tuple is by creating a list inside a parenthesis. So you can say 0, 2, 1, and 3. And obviously you can see if that is something that is giving you okay results. So print it, and you should see that your tuple is 0, 2, 1, 3. But again, if you want to scale your tuple, so let's go ahead and the print line tuple times print, and then say scaled tuple 1. Let's go ahead and say scale tuple 1, and then let's say this one is times 3. So now it's going to copy it 3 times, like the list. Right. 0, 2, 1, 3, the same thing. So in this case, as you did before, you would say tuple to array equals np.array and tuple 1. And you want to scale this one, so you're going to say scaled array from tuple equals tuple to array times 3, or any number really, and then you print your scaled tuple. This is equals, and then comma, my variable. Print, and then you have that 0 times 3 is 0, and that 2 times 3 is 6, and then so on and so forth. So another demonstration that you just, if you want to do arithmetic operations on your lists and tuples, you need to turn them into arrays. And this is also how you do it. So those are your tuples, your lists, and your arrays. Now, obviously, we're doing this example with 4 or 5 objects in a list, but this could be thousands of lines, thousands of elements in your list. So in that case, you do exactly the same. You probably have to read it from file or generate it using random numbers because you're doing statistical analysis and so on and so forth. Now we're going to talk about for loops and while loops. So let's create a block of comment here. It's for loop. But also, if you want to change the size of your font, you can go to File, Settings, and under Editor, you're going to go to Font, and you can change your font to whatever size you want. So change it to 20. You can also change the font of your IDE, also by going to File Settings, but instead of Font under Editor, you're gonna go to Appearance, and on Appearance you can actually change the background. So right now it's in Darkula, which is black. That's the one I like. You can go to Light, Windows, and turn it to white underneath. You can choose whichever you want. And I'm going to go back to 18, and I want to also change the presentation mode to 24. Apply. So now the IDE and the font is larger. I think it's easier to read. So now I created a file, an array called temperature, which is the one I want to use. So I'm going to create it again, which is temperature is equal to np.arrange and it's going to be 20 positions long. So I'm going to print my value of temperature, which I have shown here, but I'm doing it again for you to see how it's done. So comma, this is my variable to print, and this is the text that I want to use to add in my print command. So if you run it, it's Shift Alt F10, and you're going to run my list. So this is what we have. Temperature equals 0 to 19. Remember, is your value in your arrange function minus 1 because you start from 0. And this is, we're going to assume values of temperature of a test that I performed. Of course, later on, you're going to read a file and you're going to have your own temperature values. But for now, until you learn how to read the file in a few sessions, we're going to assume that these are my temperature values so that we can learn how to use Python and not so much focus on the true values of temperature. So for a for loop, the goal of the for loop is to perform iterations over a command line. So the for loop is the same concept for every language, but the syntax may be a little different. So for Python, you do a for loop by typing for, and the variable that you want to iterate over your task. So my variable to iterate over is going to be I. It's typical I, J. You can use a, you can use a word iteration. You can do whatever, and then it's going to start from 0. And you say in range, which is a function. Say, just easy example, 5. And this is important. This column part is important. And enter. This is the most important part in Python for loop. To remember that you have this is the spacing, which is called indentation, so that Python interprets that you're doing a for loop. If you were to write something here, print I, say I equals, if you were to run this, you're gonna get an error, and it's because you're not respecting the syntax that you need. So for that, you need to press enter here, or from here, press tab. Either way. So enter or tab. And now when you run this, you're going to now see that you're doing I equals 0, equals 1, equals 2, equals 3. So let's go ahead and say, print I. Now to exit for loop, now you go back to your first row of the ID. So no space, no tab, no gap. Let's say print I equals I plus 1. And let's debug this part. So to debug, you go to run, debug, or simply Shift Alt F9. So if you realize I don't like to use the mouse very much, and it's because sometimes when you use the mouse, you can make mistakes like drag things and the temperature value is not temperature anymore. And now this is something weird, and it's hard to track what's the error if you're doing that several times. So I refrain from using the mouse as much as I can. I use the arrow key and the shortcuts on the keyboard. So Shift Alt F9 and run this. So now here, for this particular case, you do use the mouse, which is debugging. That's the only case I try to use the mouse. So you're going to start running, and those red dots are where you want to place you want to stop your code. So you just simply click on this side of the IDE to stop your code. So I'm gonna stop at the for loop and then run. And now you have everything from line 0 to line 53 saved, and we want to iterate over the for loop. So for that, you step over, or better yet, you can step into. So let's go ahead and see what I is. So I equals 0 because it just went through the first line, and it's gonna print it. To see what it prints, you go up here, debugger, console. So to print, you check under console. To debug, you go to debugger. Now next line, I equals 2, I equals 3, I equals 4, and since it did 0, 1, 2, 3, and 4, then it finished because it's 5 times and starting from 0. So it finished. So that's the for loop. So what we can do is say something more interesting, like for I in range, the length of my temperature vector. So this is a number, which is going to be the size of this, which is 20. So for I in range of the length of my vector, print I. So now it's going to do it 100 times. Sorry, 20 times. So if you notice, this is really the amount of the number of times that you want to go over your task, which is print something. And this could be a large task. Many times is 100 lines of code just within the for loop, and this could be 20,000 times. This could be 20,000 times in our for loop. In fact, what we can do now is we're going to create a matrix that is going to be, say, temp field. My temperature field is going to be a NP matrix, so it's populated with zeros and parentheses inside, knowing that it's a matrix, and it's going to be length of temperature by length of temperature. So there, if you want to do it again, go ahead and erase and do NP zeros. So it's going to create parentheses again, and then it's going to be the size of the rows, comma, the size of the columns. So I want the size of this vector. I want 20. Basically, I want this 20 by 20. But since this temperature vector could be 20 my first test, and they could be 200 my second test, and my third test could be 55, then I'm going to make this dynamic by saying the length of my temperature vector, and it could be depending on what you want. If you're gonna have only 1, 2, or 3 columns, you just type whatever you need. It's your data. I want to have a square or a rectangular matrix that is 20 by 20. So my temp field now is a matrix. And what I need to do now is that I want to bring my temp field inside my for loop. And I'm going to say that for the first value in my row, I am going to write I. In other words, temp field, to access the field, to access the matrix, you use square brackets. In I, comma, what row? Let's say 0, my first row, is equal to I. So what this does is that you have your matrix that is going to be jumping over each row. In other words, if my temp field is a matrix of position here, say position here, 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 and it's going to be 3 by 3 here. So this is a matrix with 3 rows and 3 columns. This position here is the position 0, 0. This position here is row 0, column 1. This is row 0, column 2. And this would be row 1, column 0. Row 1, column 1. Row 1, column 2. And lastly, this is row 2, column 0, row 2, column 1, and row 2, column 2. So this is a matrix of 3 by 3. Matrix with size of 3 by 3 equals to that. So this is the position. How do you access to this position is by matrix 0, 0 is this, which is number 1. And matrix in position 0, 1 is another number, whatever you have to. And this is another number, 3, etc. So now there are properties of matrix. If you remember your linear algebra class, they could be orthogonal, it could be rank n or m, or it could be independent rows, independent columns. So it's really the property of the matrix which is determined by the values inside your matrix. Right, so you just remember your linear algebra, or you can go back to your notes on that. So in my case, I have a matrix of 20 by 20, and I want to say that in all my rows, but the first column, I'm going to write the value of I. So I'm going to plot or print this variable temp field, which is a matrix. And there you have it. It's not very easy, so let's go ahead and do something easier to watch because it's a little too big. So let's go to my temp field with a debug, and now we can view the array here. So now notice that everything is zeros except for my first row. Sorry, my first column. All the rows are I, so 0 all the way to 20, and all the columns everywhere else are 0, because I said that for my matrix, in every row for the first column, write the value of I within the for loop. Okay, well, so I can also do this, do for j equals to 0 in range, and length of my temperature, now column, enter. So delete, what I did there was delete all the spacing here and enter, so that the indentation is respected, otherwise we'll get an error. And I'm going to say that for I comma j, I am going to have a value of I, and this will give me a diagonal with the values of I. So in fact, let's do print temp field outside. That's okay then. So let's do run. I can see there is something that not quite right. It's not what I wanted to show. Okay, so I can work with this. Let's go ahead and do, I did a debug, and now I'm going to print my temperature field. So I'm under debug mode. So what it did is that it's going over each row in each column, doing that. But I said that what I want is only in my diagonals. Everything else is 0. So for that, I can simply do if I equals j, meaning if my diagonal is 0, 0, and 1, 1, 0, 0, and 1, 1, and 2, 2, because this is 0, 1, and this is 0, 2. This first row has positions 0, 0, 0, 1, 0, 2. Notice the diagonal of my matrix is 0, 0, 1, 1, 2, 2. So I can say now, if I is equal, but now since it's equal, saying is the same thing, not assigning the value, saying when it's assigning the values equals to something, when it's saying if this is the same thing as, is 2 equals. So if I equals j, column, delete to respect the indentation. Then write this. Else temp and I comma j equals 0. And let's go ahead and run this code. I can see that it's doing what I want now. So debug on line 66, click on the line, and then shift alt F9 to run debug. And then let's go to my matrix called temp field. And now I have a matrix that has the value of I right on the diagonal. This is what I wanted to do. So I did with for loops and an if. Now, if that matrix is orthogonal and is linearly independent, it's a different story. But let's assume that I want to solve for vector field. In other words, remember that if you have matrix equals to, let's do another block of comment here. If you have a matrix that is A equals to something, so you have 3 by 3. Actually, let's make it faster. If it's 2 by 2. So you have a matrix that is 2 by 2. And you have also a vector that is 2 by 1. One and 2. So I have a matrix that is 2 by 2 and a vector that is 2 by 1. There's a system that is A times X equals B, where I can solve for X by doing A. I don't know if you remember this, linear algebra again. Inverse times B. So if you remember this, you have, in other words, you have this. Another way to write this is this where this is x1 here. This is also very common in control theory, so I'm sure most of you know what I'm talking about. X2, and then this is equal to B1 equal to B2. You can find the value of x1 and x2 by inverting the value of your matrix A. Okay, so that can be done in Python, saying very simple in one line. In one line, you can find the value of your x, saying my x is equals to li nalg solve. But there's an error here, and he doesn't know what this is. Not a problem. What we can do is that we can import the library where we have all these scientific functions. So let's go up here and do import scipy, and well, actually I only need the function. So from scipy import linear algebra. Very nice. So now I can go here to my code, and in linear algebra I can say x equals linear algebra. Now understands what I want. Dot solve, and I want to solve my matrix and my temperature field. Print x. Now I don't promise anything because I don't know if this system is singular meaning that it has a solution. I just made up those numbers and now I'm all the way into the solving the system. But let's see what happens here. So my list is not sure, that's okay. I just want to solve that and run it. My list is not running parallel. Would you like to stop the running one? Yes, stop and rerun. Oh, he did not like that because it's saying that in 986 temp field. Let's see what the error means. Debug. First, I want to make sure that this is 20 by 20 and this is 20. Oh, okay. My temp field. Yeah, they're the same dimensions. Okay, so let's read the error one more time. Oh, matrix is singular. Okay, no wonder. So matrix is singular. So it has no solution. I wonder what would be a nice way to fix this, simple way to fix this. I equals here and else. Let's write 1 instead of 0. Okay, you did like that. Okay, so let's see what it is. So my list, let's do a debug and let's check what x is. I need to debug to the next line. So run and x. So before I had a debug point on line 67. So I removed the point and now if you have this blue line on top of the line, it's because that's the current line that the code is running. So very interestingly, this solution of the solution between my 20 by 20 matrix in my 20 rows by 1 column vector is 1, -18, 1, 1, 1, 1. Interesting, because everything is 1 except for the first column. So let's see what's on the first column that is so interesting. Temp field 0. The first one is everything is ones. That's interesting. And remember that my temperature vector is the one from 0 to 19. So x, yes, x is 1, 1, 1, 1, and negative 18. All right, so that solution does have that system of equations does have a solution. So interestingly, now we have solved with a linear algebra command, which is linear algebra solve the matrix and a temperature. So I wanted to talk about this because it's very useful for your controls systems, for your numerical methods. For a lot of your classes, you'll have to deal with matrices where you have to solve, and you can look into this command much more and go to scipy.org and look into all the options that you have. So another interesting thing that you can do is now x is a vector, but temp field is a matrix. So if you want to multiply two matrices, you can do, let's say, z equals temp field times temp field. And what is going to be z? Let's debug this and look into z. So z is a matrix of 20 by 20. And notice that is the multiplication of the first temp field matrix by the temp field matrix. So you're multiplying the matrix by itself. So if you go to temp field, we have that 19 by 19. 19 by 19 is 19 times 19 equals 361. And you have 19 by 19. But remember, the matrix is not 361 because matrix multiplication is a whole row by a whole column. Therefore, basically this, in my multiplication matrix Z, this column here is the whole row 19 times, so the first, in other words, going from my temp, I'm doing temp field times temp field, this matrix time itself. And we're saying that the 19th position is basically this row by this column. So we're saying 1 times 1 plus 1 times 1. Therefore, the answer of that operation is 380. Okay, so perhaps there was a bad example to it, such a big matrix, but if we do a smaller one, say my mat equals np zeros of 2, 2, well, we don't even have to go that far. We can say that is my mat and 0, 0 is equals to 1, and in 0, 1 it's equal to 2, and in 1, 0 is equal to 0, and in 1, 1 is 3. So if I do multiply mat, this is my mat matrix operation, my mat at my mat, meaning multiply those two things, and if I print multiply mat, let's do two things first. Let's print my mat by itself so we know what we're seeing. My mat, and then we're going to print the multiplication. This has to be under quotation marks because it's going to be a comment. So multiply my mat. For that, I'm going to say print, comma, this is equal to, comma, my multiply my mat. Okay, let's run this. My mat in 0, 0 equals 1. What does this error mean? It's not defined. Why is not defined? Oh, because this is capital M. And PyCharm even told me with this red line underneath there's something wrong, and I didn't even catch it there. So my mat. So when there's a red line under there, or there's a red line here, it's because there's something wrong. In Python will help you figure out what's wrong in many cases. So my mat, what is wrong now? There's no red line. Okay, good. So my mat, this is a good moment. This is a good time to do this jump line so that we have the matrix organized by columns and rows. Let's do it again. Run it. Shift Alt F10, and then we have my mat is 1, 2, 0, 3. So this is not dependent matrix. This is linearly independent, because you cannot have a combination in any row, any column by multiplying or adding or subtracting any other row. So when you multiply this by itself, you're gonna have 1809. Why? Because if you take this 1 and multiply the first row by the first column, you're gonna have 1 times 1 equals 1, plus 2 times 0 equals 0. So the first one is 1. Then for the second one, you're gonna have 1 times 1 equals 1. Let's write it here. And another one here. I want to multiply by this and by this. So this is equal to, so the first one is 1 times 1 plus 2 times 0, comma. The next one is 1 times 2 plus 2 times 3. That is equal to 2 plus 6, and that's 8. The bottom one is 0 times 1 plus 3 times 0, and the last one is this times that, and the last position. So 1 times 2 plus is the second by the second. So this is 0 times 2 plus 3 times 3. So let's see what this is. This is equal to 1 plus times 1 plus 2 times 0. This is 0. This is 1. This is equal to 6 plus 2 is 8. This is equal to 0. And this is equal to 9. So 1809. 1809. So this is probably a good example for you to see that a lot of times Python is a way to apply other concepts basically without computing or coding your own problems. So thankfully, you don't have to do this for a 100 by 100 matrix, because you can get that done by doing this, which is the product of a matrix with the at. Okay, now let's do the while loop. So we can say start equals 0 and end equals 10. So we write while start is less than end, do print start, or print my number, because start, we don't want to say start is different every time, just being the strict. It doesn't have to be that strict, but instead of start, I'm gonna say my number, because I don't want start to be 1 and then to be 2 and then to be 3 and changing every time. My number, remember, no space. So my number, and start doesn't exist anymore, so my number, and this is my number. So it's going to be 0, and if it's less than 10, it's going to come in here, and it's always going to do that, because I haven't said that my number is equal to what my number was plus 1. Now in Python, you have a nice way of saying this, is plus equal 1. So let's go ahead and do a print one more time, but outside. Let's get rid of the indentation here, and plus 1. And there you have it. It's 0, 1, 2, 3, 4, 5, 6, 7, 9, and I didn't need the plus 1 because he did. Python recognized that it's plus 1. Now it's finished, and now I'm adding another one. So this is how you would do a while loop. It's very simple, except for in for loop you have a way to stop, saying for until a number. Here you say while this is true, do something. So you have to inside have a variable or a flag or something that will tell him this is not true anymore at this instant.